All right, I'll be teaching you all about Theorem 6. Euclid 1.6 means Book 1, Theorem 6, as you know. You should have the sheet in front of you. The first thing I'm going to teach you is how to state Theorem 5, which some of you have already passed, as a pictogram. What Theorem 5 says is if you have an isosceles triangle, that is a triangle with two equal sides, then the base angles are equal. All right, you prove that with your 13-step proof called the Pons Asinorum. Now, Theorem 6 of Euclid is the converse. The converse means we're going to take these two premises and we're going to reverse them. This is the sides are equal, and this is the base angles are equal. So we prove that if the sides are equal, then we can prove that the base angles are equal. Theorem 6 is going to prove that if the base angles are equal, then the sides have to be equal. Euclid will often do this in the elements. He'll take a theorem and he'll switch the premises and he'll prove the converse of the theorem as the very next theorem. All right, so let's get a few vocabulary words down so you can understand this and talk about it in a more intelligent way here. So, conditional sentence is any sentence that you can write if P, then Q. All right? P and Q are sentences. They are statements which are either true or false. Okay? A statement which we call true or false, we can call a premise. Okay? So a premise is any statement either true or false. All right. So in this conditional sentence, P is a statement such as a triangle has two sides that are equal. And Q is another statement such as a triangle has base angles that are equal. The conditional sentence says that those two sentences, or those two premises, are linked logically. That if you believe P is true, then you have to believe that Q is true. All right, P is called the hypothesis. It's the if part of the sentence. And P is the hypothesis in this sentence, and Q is the conclusion. It's the then part. All right? So P and Q are the premises of this. Well, to form a converse from any conditional sentence, you simply reverse the premises. So the converse of if P, then Q would be if Q, then P. All right, and so maybe we've talked about this once already in this class, but if a conditional is true, the converse is not necessarily true. It could be true, it might be false. And the famous one that I use is, if it's raining, then it's cloudy. P would be, it's raining. Q would be, it's cloudy. And that is pretty much 100% true. If it's raining out, you look up at the sky, the rain has to come from somewhere. It comes from the clouds, right? All right, so if it's raining, then it's cloudy is almost 100% true. But if you make the converse, if it's cloudy, then it's raining, how true is that? That's not very true. There's tons of times when it's cloudy when it's not even raining. Or maybe it's snowing instead of raining, all right? But if it's raining out, for sure there's clouds, right? So, so that tells you how these two statements are related to each other. If two sides of a triangle are equal, that means the angles opposite those sides, that is the base angles, are going to be equal. That's theorem 5. You prove that using 13 steps. But theorem 6, we're going to prove in a totally different way. We're going to prove that if the angles are equal, if the base angles of a triangle are equal, then it is isosceles, or then the sides opposite those base angles are going to be equal. All right, and we're going to prove that with a new method of proof that we have not used yet. All right, and that method of proof, well, let me first just tell you, the shortcut name for it is indirect proof. All right, indirect. So that's another name for this, but it has a Latin name, and that Latin name is reductio ad absurdum. Reductio ad absurdum. Literally means reduction to the absurd, okay, or reducing to the ridiculous or the absurd. Absurd, I forgot the S. There we go. There we go. So that's literally what it means. However, it is a method of proof where we prove something is true by proving that its opposite has to be impossible. All right? So let's write that down. A method of proof where, oops, I got to move this up here. Sorry about that. A method of proof where we prove something true by proving its opposite is impossible. All right. So Euclid is going to use this a lot in proving converses true. All right. And in order to prove something is true by proving its opposite is impossible, you basically have to start with something that has an opposite. Okay. So in this case, either these two sides are equal or they're not. All right. That's called a dichotomy.